If I can't do that, if I cannot add 10 with this variable x, they will kick the hell out of me. Now the question is, what is scope? We have done all this to understand scope. Now the question is it the parent context of function 1? Now the question is, what is closure? Closure is nothing but this backpack that this function is carrying. Hello everyone, how is everyone doing? I hope everyone is doing great, and today we are going to talk about the most popular concept of JavaScript, closure. So without any further ado, let's get started. Well, the question is when closure comes into the picture. The closure comes into the picture when we return a child function from a parent function. So here you can see this child function, we have declared it here, and then we have returned the child function from inside this parent function. Okay, now when we do that, a problem arises. Now closure comes as a solution of that problem, and we will get into that. Before getting into that, let's see the overview of this lecture. In this lecture, before understanding closure, we need to understand what is lexical scope and scope chain. It is really important to understand that. Then we will see the closure in terms of execution context. Then we will see the closure using some code. So in the code editor, we will see how the closure works actually. Then we will see some practical use case of the closure. And this execution context, it is very important to understand. If you have not seen the previous lecture on execution context, please go and watch the previous lecture first, because that's a prerequisite for this lecture. If you did not see the execution context, then you will not understand this lecture. So it's a very important one. Now let's get into the lexical scope and scope chain. Well, before understanding lexical scope, we need to understand what is actually a scope. So to explain scope, I have taken here this piece of code that we shall execute line by line, and in the end, we shall understand what is scope. So let's start the execution, and we will only see the execution phase. We will not go into the memory phase. Okay. So here in this line, execution will start, and here it is saving 10 in the variable x. So let's do that. Then it is declaring this function 1. Then in the end, it is calling the function 1. So there will be a new execution context, basically the function context inside the global context. So this is our new function 1 execution context. Okay, so let's move the function here. Here we have enough space. That is why we are moving the functions from here to here to make a better visualization for you. Okay. But when I shall explain the lexical scope and scope chain, there will be context inside context inside context. So there will be multiple contexts. So we will not have enough space. In that case, we may not move the code inside the context, but we shall definitely see the execution from here. So now this function will start its execution. And here it is basically declaring a variable y with value 20. So in the memory, y will be 20. Then it will move to the next line, and here it is console logging y. So what it will do, basically it will first look into its own context, and here it found the y. So there is y is equal to 20, so it will console log y. So just to see the output, let's think this is our log, and here it will give the output 20. Okay, and now it will execute this line. Okay, so it will basically console log x, and it will first look into its own context. There is no x here, so it will move to its parent context. Basically it will look into the parent context, and there is x, so it will basically bring this value here and it will log it. Okay, so let's log it. So here it will be 10. Now the question is, what is scope? We have done all this to understand scope. So scope is like an area where the variables are accessible. For this execution context, this function 1, we can access its own context and its parent context. Remember, child can access the parent context, but parent can never access the child context. This is the scope for the function 1 execution context, its own context and its parent context. And whatever is declared here, like any variable or any function, like this function, this variable, all are accessible for this function here. So the scope, you can think of it like an area where the variables are accessible. In terms of this execution context, the area is this. For the global, only this. It cannot access its child context. So I hope the concept of scope is clear. Scope is nothing but the area where the resources are accessible, like variables, functions, objects, arrays, anything. And it works like the child can access the parent can never access the child. Now the question is how the parent will be determined. That depends on the lexical scope. So let's get into that. Well, to explain lexical scope and scope chain, I have taken here a simple piece of code. There is basically a variable in the global and two functions, and I have called the function here. And the function 1 has been called inside the function 2. We shall execute this piece of code line by line and we will try to understand what is lexical scope. So let's start that. And to save time, I will only show here the execution phase, not the memory phase. We shall avoid that. Okay, so for this line here, it will be x is equal 10. And for this function 1 and function 2, it will be saved in the memory. Okay, so function 1 and function 2 is in the memory and the variable x. So now the execution will move and it is here basically calling the function 2. So function 2 execution will start and a new execution context will come into the picture. So now here the function 2 execution context. Now the function 2 execution will start and here it is basically saving 20 in y. Okay, so let's do that. Y is equal to 20. Now the execution will move and here it is calling the function 1. So a new execution context will come into the picture and the pointer will move to function 1. And see, it is the function 1 execution context. Okay, so function 1 execution will start and in the first line it is basically console logging y. So to find the y variable, first it will look into its own context and there is no y, then it will look into its parent context. Now the question is this context basically the context of the function 2, is it the parent context of function 1? So that is the big question. And here lies the answer of the lexical scope. So lexical scope means basically parent will be defined by where the function was declared. Like this function was declared here in the global function 1. Although looking at the execution context, it seems like the parent of the function 1 is the function 2 because function 1 execution context is inside the execution context of function 2. Okay. And that is because function 1 has been called inside the function 2. So it may seem like this is the parent context and it will get the y from here. That is not the case. Why? Because JavaScript is lexically scoped. Lexical meaning related to word. And when we write word, there is a specific place for the word. So we have to check in which place this function was written. That will determine who is the parent and who is the child. So the function 1 was written in the global. See here, the function 1 is residing in the global context. So global will be the parent for the function 1, not function 2. This is why JavaScript called lexical scoped language. If it didn't happen, like where the function was called, that will determine who is the parent and who is not the parent. That is called dynamically scoped language. But if it defines the parent by where the function was written, that is lexical scoping. So when it will try to console log y, first it will check its own context. It is not here. So it will look into its parent context. Here, there is no y. Okay. So it will show error. Okay, so just for this execution sake, let's move the execution here to this point, although it will not move this point because here it will show error. So to console log x, it will first look into its own context. There is no x. Then it will look into its parent context. There is x. Here it will bring this 10 from here to here and it will log 10. So this is how it works. Okay, so just to summarize, what is lexical scoping? Lexical scope means the scope will be defined by where the function was written. So basically, who is the parent, which context it can access, that scope will be determined by where the function was written. So this is what is lexical scoping. Now to understand it better, let's take another example. So here there is variable x in the global, then function 2, and inside the function 2, function 1 has been defined, and function 1 has been called here, and in the global, function 2 has been called. Now let's execute this application and let's see what happens. So initially in the memory, there will be x, which will be 10, and function 2 will be there. So now the pointer will move here and it will execute the function 2, and it will be here, the pointer basically, and a new execution context will come into the picture. Now here we can see the function 2 execution context, and it will execute this line first, and here y will be 20. Then the pointer will move to the next line, and it is basically saving the function 1. So function 1 has been defined here. Now the pointer will move to the next line. Here in the function 1, basically function 1 is being called. So it will move to function 1, and a new execution context will come into the picture. And here it is trying to console log y. So first of all, for this function 1, it will look into its own context for y. But there is no y here, so it will look into its parent context. Now the function 2 is the parent for function 1. Why? Because function 1 has been defined inside the function 2. So lexically, I mean the where it has been written in that way, function 2 is now the parent of the function 1. So it will first look into here, and it got the y here, and it will take this value and it will console log here. So let's think this is our log. So it will log 20. Okay. And the pointer will move to the next line, and this line will be executed. And this is basically trying to console log x. So first of all, it will try to look into its own context, and there is nothing here. Then it will look into its parent context. There is no x here. So it will look into its parent context, which is the global. Okay. And there is x. So it will take this 10 from here and it will log this 10 here. Okay, so let's log that. And this hierarchy of the scope is basically called the scope chain. This is scope chain. First, it will look into here. If it does not find it here, then it will look into its parent context. If it does not find here, then it will look into its parent context, then its parent context. This is scope chain. Okay. So I hope you have understood what is scope chain. So now our execution will end here. So this is what is basically lexical scope and scope chain. So our lexical scope and scope chain is clear now. Now let's see the closure in terms of execution context and what is problem and what is the solution. Well, now we will see the closure in terms of execution context. For that, we have taken here a simple piece of code where the child function is being returned from the parent function. And I have already said, when you do that, a problem arises. And closure comes as a solution of that problem. So we shall execute this piece of code line by line, and we shall try to understand the problem and how the closure solves that problem. And to get the full picture, we shall also maintain the call stack. Okay, so let's start our execution phase. And for simplicity's sake, we will only see the execution phase, not the memory phase. We shall avoid that. So initially in the call stack, there will be global. Okay, so here in the global, it is basically defining the parent functions. So in the global context, the parent function will be saved. So pointer will move to the next line here. So it is basically creating a variable child func, and it is calling the parent function here at the right side. So a new execution context will come into the picture, and in the call stack there will be this parent function, and execution pointer will move there. Basically here inside this parent function. So in the call stack it will be parent now. So now here we have our parent function execution context. Okay, so let's move our code to this context. So here our execution basically will start in this context. So the first line basically it is saving 10 in the variable x. So it will be inside the parent context. So now the pointer will move, and here it is basically defining a function, child function. So it will be saved in this parent context. Now it will move to the next line. And here it is basically returning this child. And we know when a function returns something, the whole function will be removed from the context. I mean, the context will be gone. And it will also be removed from the call stack. So basically, this child function will be returned. And this child variable will basically point to this child function. And where is this child function? This is in the global context. So it will be here. So let's write that first. So remember this child func variable, basically this one, it is pointing to this function, and it is basically this child function. So I have pointed here out as well. Okay. Now this context will be gone. Okay. And it will be removed from the call stack. So let's remove it from the call stack. And let's not remove it directly. We shall need it to explain what is the issue. So let's just cross it that this is gone. So by this cross, basically we are saying this function is gone. Okay. Basically this function execution context is done. So it will continue its execution here. And here it is basically calling this child function. This child function. Okay. Now, what is the issue? The issue is this is the child function, and what it is doing, it is trying to add 10 with this variable x. But where is this variable defined? This function does not have that variable. It did not define it. It was defined in the parent context. Basically, parent defined it. Here we can see that the x is equal 10. But how is it going to get it? Because the parent function returned something. So parent is gone from the context. Everything here will be removed. So when it will try to add 10 with this x, it will show error because there is no x. X was defined here. Okay, so this is the issue. When we return a child function from a parent function, and if the child function uses any resource from the parent function, basically that was defined in the parent function, the issue arises. So it needs this variable. Okay, so if we look at this child function as a character, this character is basically saying it to its parent that, Mama, if you go away and you put me out here in this global cruel world, they will make me do work. They will call me and they will give me tasks to do. If I can't do that, if I cannot add 10 with this variable x, they will kick the hell out of me. I cannot survive without this resource that you created. Either you give me that or you take me with you. So Mama says, okay, child, take this resource with you. I am giving it to you as a legacy. So the child takes it in its backpack and it goes here in this global world. And Mama goes away. Now, when this child function is called, so there will be a new execution context. Okay. And this output variable, it is basically defined here in this global. So let's do that. So now when the child function will be called, there will be a new child function execution context. Okay. So now it will try to execute this piece of code here. Now here, when this line will be executed, it will basically try to add 10 with this variable x. Now this function has this x variable in its backpack. Okay, so it will take that value 10 from here and it will add 10 with this 10. And it will store 20 here in this result variable. Okay. So this is how it works. All right. Now in the next line, it will basically return this result. So that 20 will be basically stored in this output, which is defined here basically in this global context. So here it will be 20 and it will console log the output. So this is how this execution will go. Now the question is, what is closure? Closure is nothing but this backpack that this function is carrying. Okay, that it got as a legacy from its mama. All right. So this is basically the closure. So the function stores this variable x in some place when it is coming out of the function so that later it can use this. And that is basically the closure. Okay. So I hope you have understood the closure in terms of execution context, what is actually the closure. And one more thing here I missed basically, when this child function will be called, when this execution context will be created, of course, this child function will be at the top of the call stack. So without being at the top of the call stack, no function can start its execution. So child will be, of course, at the top of the call stack when this execution started. Okay, now we will see the closure using the code and we will see actually where it saves the closure. So let's get into that. Well, here we are in the VS Code, and this is the very same piece of code. And here we have the parent function. Here we are calling the parent function. It is returning the child function here, and we are calling the child function. It is giving the output. Basically, this 20. Okay. So let's first console log it and see if it is giving the right output. And we will run it in the browser for better understanding so that we can see the log better. So for that, I have taken an HTML file and I've just added this closer.js file, the file that I created. Okay. So let's run this HTML file. So in the browser, it is running now, and this is giving hello basically from this. Now let's open the developer tools and see the console log. So we shall go to the console, and what we shall do for better visualization, we shall pop out these developer tools. So if you click here, so now the developer tools and the browser kind of separate. Now we will only keep these, and we will keep the browser and the VS Code side by side. Okay, so we did not console log it. Let's first console log it. And see here it gave the output 20. Now let's get into the closure. Before looking into the closure directly, we need to understand one thing, that almost everything in JavaScript is an object. The function is also an object. So how can we prove that? So like if I write an object here, very simple one like name Jacob. Now if I want to access it, if I just put dot, see it is giving this name as the suggestion. To check whether something is an object or not, if we just put a dot after that, and if it shows properties, that means for sure this is an object. So we can check whether function is an object or not. So let's remove it. So for example, let's just create a function. So let's create function, a sample function basically, and let's just return hello. Now if I put dot after func, see it is showing bunch of properties here. Apply arguments, bind, call, caller, length, name, prototype, to string. If this func dot is showing bunch of properties, that means this is an object. So basically what I'm trying to show here is that the function is also an object. So it has bunch of properties. The properties we can see here, we can use them. They are visible to us, but not all properties are visible. There are some hidden properties that JavaScript uses internally. Okay, we cannot access them here in the code, but we can see them in the console log. And we shall try to see in which property the closure is actually set for that function. So let's do that. So the closure we have to see definitely in the child function. So let's console dir basically the child function. We are not calling the function, we are just logging it. And console dir is nothing but console log with more information. Okay, now at the right side we can see it basically console logged this child function, and this child function, if we expand it, we will see bunch of properties in it. So let's check that. So see, there are bunch of properties, and there are some special properties. We can see them like with the square bracket, and they are the hidden properties. Here we can see 3 hidden properties. We need these scopes. So let's expand that. Here we can see the first element of the array, basically our closure. Okay, and see this is the parent closure. It is coming from the parent, and it is saving x10 here inside this. So when it is trying to add x with this 10, it is basically taking from this backpack. Okay, this is the backpack. So if the child function used like 10 properties here, it would have saved all the properties here in the closure. So this is how it works. So I hope we have understood how actually closure is saved in the child function, and we have seen it in the console log using the browser. Okay, so we have seen the closure in the code, where it actually saves, how the function actually saves it, what is the backpack. And now let's see some practical use case of the closure. Because of this feature, we can do many things. We will see some of that. Okay, so let's get into that. So here we are in the VS Code, and we shall basically see some practical example. First, we shall start with a simple example like counter. We'll develop a counter, and we will see how the closure can help us. Okay, so let's create a function counter, and every time this function will be called, it will basically do count plus plus. So basically it will increase the variable count by 1, and we shall declare this variable count in the global, and we initialize it to 0. Okay, so now if we call the counter, like I have called here once, I can call here again. Now if I console log the count, it will basically show 2. So I'm running it in the node environment. So node closure.js, and here it is showing 2. Okay, so now what is the problem? We have made our count. Now the problem is, so if you call the counter one more time like this, it is supposed to be 3, but before that, if we just for some reason by mistake we just set the value of the count again like 3, the output will be 4. See, here you can see the output is 4. So there is no data safety. This counter function has been made to increase the count by 1. Okay, so this is the purpose of this function. So everything related to that should be inside this function. Only this function will handle that. Okay, but this count variable is outside this counter function. So what we can do, we can keep this count variable inside this counter function. Okay, so now this variable has been created inside the counter function. So we have to change the code a bit. So we have to return the count. Okay, so like here, I do not have the count anymore. What I can do here, like I can console log all this counter. So what I've done here, basically, I have inserted this count inside this counter function, and count is being increased by 1, and it is returning the count. Okay, so now every time I call the function, it will do the same thing again. I will call this again, and it will do the same thing again. It will reinitialize the count to 0, then it will increase by 1, then it will return 1. Here in the browser console, we can already see the output is giving basically 1, 1, and 1, 3 ones. Okay, so it is not increasing. So that is not serving our purpose. Okay, so what we could do here, basically, we could return a function, and this function, let's give it a name like count by 1. Doesn't matter, but I don't like to write anonymous functions. That reduces the readability of the code. Here now I want to increase the count, and from here the count will be returned. Okay, so now when I shall basically call the counter function, it will now return this function. So let's call it count by 1. Now when I shall console log this count by function, basically I'll call it here. So let's call it several times. Now see, it is increasing the value 1, 2, and 3. Now it is serving our purpose, and the count is inside a function. Not just everybody can access this count variable. So this count is encapsulated in this counter function. Okay, so this is serving our purpose of the encapsulation. Everything is packaged here. So our code quality has increased, and definitely this function which is being returned, it will basically save this count in the closure. So we have console do count by 1. Let's expand this function here, and this is scope, and here you can see the closure. Closure basically count 3. Okay, so this variable. So this variable is like kind of working like a global variable for this function. So this is how it works. Now let's see one more example. So now we will see the once function. Once function is basically a function should be executed only once. Even if it is called multiple times, it will not be executed. We can do that with the help of a closure. Okay, so it will be something like this. Like I have a function add range. Okay, so it will add from A to B. So there will be a result, and it is basically taking two inputs, A and B, basically two parameters, and I is initialized to A and I is less than B. So it will run from A to B, and it will keep adding this I. So if we give the input like 1 to 3, so it will add just like 1 plus 2, and it will be 3 result. Okay, so this is what this function will do. Now let's call this function. And here we have called the function 3 times. Okay, now let's run the application. We shall run it in the node environment. And here you can see it get the output 3 and this number and this number. Basically, this is a big number, so it will give a big output. So we have called this function 3 times, and 3 times it has executed. Now what we want to do, it will be executed only the first time, and later how many times it is called, it doesn't matter. It will not call those functions. And we can create a once function for that. We shall basically create a once function, and inside this once function, we shall send this add range function as an argument. So let's add the function here, basically add range. And remember, we have not implemented this once function yet. We shall implement it. Okay. So this once function will basically return another function. So let's name it add range once. And we will console log the add range once function. Okay, so I have called here this once function 3 times. Okay, but only the first time it should be called, and it should skip rest of the times. Okay, so now let's implement this once function. And here in this function, we are taking this function, basically this function as a parameter. Okay, now what we shall do here, basically we shall create a flag here, basically is function called, and initially we'll say it is false. Okay, now we shall return a function. Let's name it once. So it will take two parameters, A and B, these parameters here basically. And initially it will check is function called. If it is called, it will return. So if it is not called, we will call the function and we will set this is called function to true. Okay. So let's first set the flag to true, and now we shall call this function and we'll pass the parameter A and B. And definitely whatever that function is returning, we'll return that. All right, so what we have done so far, we have created this function once, and it is returning another function. And here in this once function, we have just set a flag. And when this function is called once, we are setting it to true. Now next time when it will be called, if it is true, it will return, it will not call the function. So our function will be called just once. Now let's run the application and let's see how many times it is actually called. See here only the output is 3. So only this one was called and they were not called. Okay, that is why they are undefined. So our once function is implemented. And we have done it with the help of the closure. Okay, so everything is encapsulated here. First of all, that is the first benefit. And this is function called value will be stored as the closure in this once function. So let's console log that and let's see that. See, I have just console this advanced once function, and here in the console log, we can see this closure of this once function. It is saving this is function call to true. This is how the closure works basically, and we can use the closure. And now the question is, where shall we use this once function? We can use this once function like if you're working on an e-commerce. In that e-commerce, of course, there will be a payment system. So the user will try to pay. Suppose the internet is slow. The user is clicking the pay and it is not working. And user keeps clicking. And that function will try to execute more than one time. That is what we do not want. We want to execute it just once. In such case, we can use this once function. Otherwise, it will try to charge the user multiple times. Now let's see one more example. Now we shall see how can we do memoization with the help of the closure. So let's see that. So here we shall use this add range function and rather than once, now we shall use memoize. Okay. And here we shall say it is add range memoized. So we shall change this function as well. It will be memoize function. Okay, so what we have done here basically, we have created a memoize function and we have that previous function basically, we want to memoize that. Now we shall delete everything here inside this function. This was for the ones. Now we shall implement the memoize. Okay, and what is memoizing? Memoizing is basically when you are giving the same input, it will not do the calculation multiple times. It will save that value for the same input in a cache. And next time when you call it with the same input, it will give you the output from the cache. It will not do the calculation. That is memoization. So this is a very important thing. It is almost used everywhere. For performance amplification, use memo in React or use callback. They all use memoization inside. Now what we shall do here basically, we shall give a big number and here I am giving the same input twice. So it will do a lot of calculation here and here as well. And let's make this third one a simple one like 1 to 100. Now let's check how much time it takes. If it was not memoized like the normal function, like let's remove the memoized one. So here we have just kept this add range function. Okay, and we are giving big numbers. Now let's run it in the node environment. Now here you can see that it is doing a lot of calculation. It is waiting. So this function is done now. Now it is calculating for the second one. See, and the second one is done. Now the third one is also done. It calculated really fast. Okay, but these two ones really took time. Okay, but they are same calculation, exactly same calculation. So if we did use memoization, first one took time. Basically, it had to do the calculation at least once. Then if we cached it, then for the second one, it could just give the output from the cache. So it would have saved a lot of time. Okay, so now we shall implement this with the memoization. So let's rename them to add range memoist. Now let's create this memoist function. So initially there will be a cache and it will be a JavaScript object. Okay. Now we'll return a function. Let's name it get memoist. It will take two parameters. Now here we shall create a key. Here this JavaScript object, it is basically a key value pair. And here the key will be basically a string of these two values. Basically this one and this number. So we can say it like this, like one, then a space, then this number. Okay. This will be the key and the value will be the output of this calculation. Okay. That will be the value, whatever the value is. So let's create the key first. A string of these two parameters. This is the key of this cache object. Okay. Now we shall check if this key in cache. If it is in the cache, just return the value from the cache. So cache array of key. What if that key is not in the cache? That means that value has not been calculated even once. So in that case, we have to call the function. So this function will take two parameters basically, and it will return the result. So let's just catch it here. So this is the result basically, this one. Okay, so it will do a lot of calculation here for these big two numbers. Okay, and we shall save this in the cache before returning it. So as this result is still not in the cache, so let's first save it in the cache. So cache array of key is basically result. Okay, and then it will return the result. So here our memoization is done. Now let's run this and let's see if it actually worked. Now when I hit enter, what should happen basically? This one should take time, but this one should end just instantly, because in this case it will return from the cache. Let's see that. So here you can see it is doing the calculation and it is taking time. See, the first one took a little time, but the second one, it just gave the output instantly because it came from the cache. Okay, so this is how we can do the memoization as well. So we have done this memoization completely and in a very nice way. Nothing is outside this memoize function. So everything is encapsulated and we are using this cache here inside this function, and it will be saved in the closure of this function. So these are the practical use cases of closure. Now there are so many uses of closure. You will see that if you research for a bit. So we have finished all four here. This part is also done. So now I hope you understand what is actually closure, how it works, and you have mastered it. You know every single thing about the closure. And if you want to study more, you can check out the official documentation of closure, this MDN documentation. And also, if you want to study the execution model, you can check out this MDN documentation. If you want to dig more, then you can definitely, the link will be given in the description. And if you're new to this channel, please don't forget to subscribe. And if you like the video, please give it a like. So take care of your health, keep growing your knowledge, and keep applying your knowledge. Take care of yourself. Bye bye.